Welcome to the MongoDB webinar from Mindmajix. Okay, so about Mindmajix, Mindmajix is the global training platform, and also it provides a corporate training. So we have a lot of courses available with Mindmajix that are IT related courses, of course, and most of our trainers are experienced trainers and who has a real time experience and all. Coming to the agenda, so today we'll be talking about mostly about NoSQL databases and particularly MongoDB. As you all know, MongoDB is a NoSQL database. Okay, so this will be our agenda today. So introduction to NoSQL database, what is MongoDB, why we use MongoDB, what are the key features, and the components and architecture of MongoDB, data modeling. So not exactly in the same order, but yes, we will be discussing exactly all these things today, and also the career opportunities. So first and foremost, I would start with the career opportunities because then you'll understand. You'll have more interest into these things. Like if you see in the market right now. Even though in these hard times we still see a lot of requirements for MongoDB, and tomorrow there will be a lot of requirements for MongoDB because it is the most. So as I was saying, MongoDB is in good demand, and there will be a lot of requirements for MongoDB in future. Okay, so uh, how many of you actually know what a NoSQL database is? I mean, you can ping me. For MongoDB, we need SQL. No, we don't need SQL for MongoDB. But if you have prior, relational database knowledge, it will be added advantage because a lot of MongoDB concepts or DBA concepts will be the same. It's just that the architecture and the processing and the working of the MongoDB will be a little different. Okay. Uh, so I'll just assume most of you have some basic idea about what a NoSQL database is, but still I'll go with the explanation of those things. Okay. So basically a NoSQL database, NoSQL. So its abbreviation stands like not only SQL. Okay. So SQL is the relational structured query language. Okay. So basically, if many of you are from Rdbms background, maybe Oracle or MySQL or MS SQL or some relational background and all. So most of you know that for you to create a NoSQL database or to manage a NoSQL database, you have to first create a table. Okay, create a database, create a table, create a schema for that, define a schema for that, and only then insert the data into that schema. In the sense is what are the column name and what is the type of the column name. You have to mention those before inserting some data. So that is how a regular a regular rdbms works. But with the invent of NoSQL databases, it is all dynamic. Like you don't have to define a schema initially to insert the data. So that is one of the major advantages that you have with the NoSQL databases. Okay, and what are the other things? I mean, this is just one of the features that is useful for you as a DBA to work towards the NoSQL databases. Apart from that, uh, let's talk about what a NoSQL database is, how many types of NoSQL databases are there. So as I said, not only SQL, so it has additional features. But again, NoSQL database, MongoDB is not the only type of NoSQL database that is in the market, but there are also other types. MongoDB comes under the category document based. Okay, so document based is all the data is stored in a JSON format in a document databases. Okay, apart from that, we have graph based databases, key value, white column. So ScyllaDB and Cassandra comes under the white column. So these are different types of NoSQL databases. Okay, so we were talking about the advantages or the benefits of a NoSQL database. When it comes to a relational database, what you say is the cost is too high to get the licenses or to maintain it on a dedicated servers, high-end servers. It is really costly for us. And also today the market trend has changed. The invent of big data, like this, the data that we are storing, it's huge, humongous, we can say. Like initially we used to think about redundancy of data to be a defect, but right now we are maintaining redundancy to have a high availability. right? And also day to day, the it is assumed that in 2020 itself, each person will be generating around 6 GB of data daily at least. If not hourly basis, it's daily basis. How is he generating, each person? Like, let's talk about social media only. So many of you are using Facebook, Instagram, WhatsApp, many other social media applications. So when you upload a picture or when you write some content, it will be stored on a database. So on that basis, if you imagine, you will be taking a lot of images, pictures, uploading pictures, or writing some content online. All these things will be done by you on a daily basis. So if you imagine, each person will be generating around 6 GB of data. So India itself has around 130 crores of population, and across different countries we have billions of population. So if you see, even if not everybody have the access to social media, even if the maximum number who's able to access the social media are generating 6 GB, that is huge amount of data for us to store and process. So a traditional rdbms is not designed to handle such huge amount of data. So it is designed to handle some amount of data. It is not designed to handle such huge amount of data, that too at a high velocity. It's every minute, every second, there's huge amount of data flowing in, so we should be able to handle those. The databases should be able to handle those. So that is when a NoSQL database has come into picture. So with a NoSQL database, what are the major advantages that we have? One thing I said is cost effective. Okay, because they are generally not deployed onto a high-end servers but onto a commodity hardwares. Commodity hardware again means you can tell your own laptop can be a commodity hardware, or these simple VMs that we are deploying. So all these are community hardwares. You don't need a high-end servers to deploy your NoSQL databases, but simple community hardwares are also enough for you to deploy. It is supported by them. Okay, apart from that, you have any questions? What is required for MongoDB? uh, yeah, so for you to learn MongoDB, there is not many prerequisites. At least you should have a basic understanding about databases. So that is more than enough for you to learn MongoDB. There is not many complications. It is easier to learn and easier to implement. At the same time, you know, uh, I mean, if you know the basics, it will be easier for you to work it on, and you can be able to learn it. Uh, Praveen, right? Yeah.
Yeah.
So for the question that Chirag asked, like I said, if you don't have a prior SQL or RDBMS, are you not eligible to learn? No, it's not like that. Even if you're a fresh candidate starting, and if you're a developer and you want to move to a DBA side and you want to learn some database skills, at least with a basic knowledge of database, it's still fine. Uh, Even if it's not there, you can still understand and you can learn those things. It is not that complicated to learn. Okay. Uh, yeah. So I'll not go to the slideshow. I'll probably keep it like this so that I can see your questions and I can answer it. Okay. That sounds good. Okay. Yeah. So where were we? Yeah. So we can use a normal commodity hardware. So that way we can be cost effective. Apart from that, the high availability concept, which is implemented into NoSQL databases, and high scalability. So these are all terms at a higher end. So how do you define them? High availability. What is a high availability means? Let's say you have a Oracle or a MySQL deployed onto a single server, high-end server. Let's say there is a maintenance going on. So if you want to go through a maintenance, sometimes you have to set a downtime and you have to do some patching, maybe a security patching or some more OS upgrade or database upgrades itself from Oracle 12 series you're going to 19 or something like the higher versions. So for that you have to bring down your servers, get a downtime, and then do the upgradations or patchings and all, and then bring back your servers. So during this time your servers will not be available for you. And let's say this is a planned maintenance. let's say there was an issue, unplanned event happened, and your server is down or some issue is happening for the connectivity. So then obviously all your clients who are trying to access your database on a web GUI or any through different applications or web logins or something like that. If it's a retail business, you have a lot of front page logins that is available. So your system is not available and you will lose a lot of business. With NoSQL database, you will try to keep your system up 99.9% of the times. Okay, so how is that possible? That is possible through maintaining replication of your data onto different machines. We'll talk in depth about those in a while. Okay, high scalability. When it comes to scalability, there are two types of scalability. There's a horizontal and a vertical scalability. What is a vertical scalability? Vertical scaling is nothing but if you have, let's talk in a simple layman terms. Like let's talk about your laptop. You have your laptop and laptop has around 1 TB of storage available by default, or maybe 512 GB of data. Let's say you're storing some movies onto your laptop and your storage is almost 900 gigs. Okay, so or 950 gigs, and you want to store few more data movies onto your system or some personal data. So now, because your system is filling up immediately, either what you can do is you can bring a hard disk, attach your laptop, and download those movies and save your data onto your hard disk, or you have to delete the older data that you have on your laptop. Let's say deleting the old data is not feasible for you. You want to maintain the old data, at the same time you want to maintain the new data. So that is when you are attaching the hard disk. This is called vertical scaling. Adding more storage to your existing server is called vertical scaling. Basically rdbms follows the vertical scaling concepts. Okay, but that also has a limitation. Let's say your laptop or even your mobile phone, it has a limited extendable memory. After that you can't expand it. The only way is you have to delete the old data, right? That is the drawback of the limitation or the drawback of a vertical scaling. What happens with the NoSQL database is it has horizontal scaling. What is horizontal scaling is, let's say you have a laptop and the same example, it is filling up and you want to add more storage to it. Instead of adding a hard disk, you add a new machine and you create a network and you add a new machine to that network. Now instead of one laptop, you have two laptops as your storage. So that way, there is no limitation here to the number of laptops or number of systems that you can add to the network. It's only the cost. Cost is the only limitation that you can maintain. As and when you can get more, you can, if you can deploy more servers, you can have more storage. So that is how high scalability is available in NoSQL database. And also you can do vertical scaling as well. It's not like the vertical scaling is not available. Vertical scaling is possible. At the same time, they also have given the option of doing a horizontal scaling, thereby increasing your overall capacity to store the data. No questions, yeah. So okay, so that is one. Are these only two of those features that we're talking about, the benefits of NoSQL? No, there are also dynamic schema, which we're talking about. So in an RDBMS, you have to define the table structure. You have to define the columns and the column values, what type of data we are going to store onto that, all those things, and only then you can insert data. With NoSQL database, it is dynamic schema. What is dynamic schema? That dynamic schema is, today, if you're storing some documents into your database, I'm talking in terms of MongoDB, we call okay, we'll talk about records. Okay, so today you're storing some records in your database. It has a fixed structure for now, like there is a name, age, and let's say country. So these are the three fields you're generally inserting. Tomorrow we are want to insert a new field which is called phone number. Okay, so now in a regular traditional RDBMS, we cannot insert a new field automatically. Okay, that is not possible over there. But with MongoDB or with NoSQL database, any of the NoSQL databases, you can change the structure of the data that you are inserting at any point, and it won't throw an error. Okay, so that is one of the advantages, because no matter how much you think about limiting the data, tomorrow there might be additional fields that you want to add. Okay, so thereby it will increase the schema, or it will allow you to have a dynamic schema, so you can insert multiple additional fields to the same data that you are inserting. Okay, replication is replicating to your data to multiple systems. So how is it useful, how is it a benefit, we will talk in some time. Okay, and it's available geographical, like I said. When I say network, it's not just local, it is global. Tomorrow, today your system is in Hyderabad, tomorrow you can maintain a system in US or maybe UK somewhere, and you can store the data related to your data, expand it into a different location geographically. Okay, so these are majorly the major benefits that you have as a NoSQL database. And like I said, there are different types of NoSQL databases available. Document base is one of the most famous or mostly used, widely used type of NoSQL database, especially MongoDB. There's a graph store also, which has Neo4j, and there's a graph store and all those things. Key value store. There is a white column, like I said, Cassandra, ScyllaDB. These are also come under white column base. Okay, uh, so now, so there are a lot of varieties, different types of NoSQL databases. Amongst them, why is the document based and especially MongoDB is preferred over the rest of the databases? Okay, so I'll show you rankings. Okay, so there is a site called DB Engines which ranks all the databases which are available in the market depending upon their performance, their availability, and their resource available, how widely they are used, and since when, how long is it used, and what is the popularity of the databases. So depending upon all these things, they have ranked all the databases, whether be it rdbms, NoSQL databases, everything. Okay, so if you see, Oracle stands as the first database, and because Oracle has been in the market since more than 20 plus of years. Okay, and also it is widely used. It's not just about the performance of Oracle, but also the the number of clients or number of DBAs that are available. Those also are the criteria which are considered. So first four, if you see, those are all relational databases. And the first NoSQL database which is ranked here is MongoDB. So amongst the NoSQL database, MongoDB is number one ranked, be it performance or popularity or the number of DBS or resources available, all those things considered. And it hasn't been in market for a very long time. It's been maybe a 10-12 years that properly, if you see, that MongoDB is into the market. So even though it is still ranked among top 5 of all the databases and top 1 in the NoSQL databases. Okay, so coming to MongoDB. MongoDB, as I said, it is also one of the NoSQL databases. Okay, it has all the advantages that in generic we have spoken about. It is high performance, high scalability, high availability, and support of multi-storage engines. And you can use it's object oriented. So any of the scripting or coding language can be used to manage or to write your codes to retrieve or insert the data into MongoDB. It's not just the Mongo itself has its own query language, Mongo Shell. Through Mongo Shell you write it, but apart from that, you can use Java, you can use shell scripting, you can use Node.js. Any of these scripting language or coding languages you can use, and you can do the the CRUD operations or inserting or managing your databases. So that availability is there. Like if you are from if you are from a Java background, you don't have to actually change everything about you can still use Java to implement or to write some queries into MongoDB. Just implement uh, it through different things. Okay, so again, uh, many of you are aware of the asset properties in a RDBMS. Like Can anyone tell me what is an ACID property, or what are the properties? Let's give it an interaction session, guys. Yep. Atomicity. Yes, Praveen, right? It's more of isolation for I. Integrity is also like you can correlate somewhere. Yes. So it's basically atomicity, consistency, isolation, and durability. So these are what any of the RDBMS databases generally have. Okay, but those are old concepts. The acid properties are the like old concepts. With the invent of new trend technologies or new era technologies, big data and all. So those doesn't actually meet all the requirements. So that is the reason there's a new theorem that is being invented for us to rank or have the databases what however they are available. So that is called cap theorem. So it's basically consistency, availability, and partition tolerance. Partition tolerance is nothing but network related. Like let's say you have your data stored across multiple data centers. So your data is stored, I mean, is been transferred over the network, right? Previously RDBMS is stored only onto a single machine, so you don't have to use a network layer to transfer the data or to replicate your data. But with NoSQL databases, you have the option of replicating your data and sharding your data. Sharding, again, the term is new for you, but I'll explain you what a sharding is as well. Okay, so that is the reason partition tolerance is also required. So this doesn't mean that ACID properties are not available in NoSQL databases. They are available, but they're not completely available all at a time. Let's say cap theorem, like I said, consistency, availability, and partition tolerance. So according to the cap theorem, any of the NoSQL databases will satisfy two of these three theorems. I mean, two of these three: consistency, availability, or partition tolerance. So does that mean it doesn't have the third feature? No, it has a third feature also, but the importance will be across two of them majorly, and then the third one is occasional, or what you say is uh, eventually that will have. Let's talk about in examples like MongoDB is basically consistency and partition tolerance is given a higher importance, and availability is also there, it is eventually available. uh, any questions? I think these are. Hello. Yeah. So consistency means the data is consistent. Like we are storing your data into multiple machines. We are replicating the same data onto multiple machines. So we have to make sure the data is consistent across all the servers, all the machines. So that is what MongoDB has considered is more important. And partition tolerance, like since I said your data is transferred over the network, so even if there is a network failure, we should still be able to overcome that issue, and we should be able to replicate it and store the data. We should not lose the data just because some network issue. So that has been handled. Most of the databases will have partition tolerance as default feature, and either of availability or consistency as a you know mandatory, and the other one as eventual. Like I said, consistency is the major feature that MongoDB has considered. That doesn't mean availability is not there. Availability is eventually available, and that also, it doesn't mean that 1 day or 2 days. It's just milliseconds or seconds of time that the data is available across different applications at all. So that also because uh, that is because of re-election of a primary. That is the only reason the availability is given lesser priority. That also election happens within milliseconds of time. So eventually, if you consider with RDBMS, it is still available at all time, but yet we consider that as a less important. Okay, so like I said, MongoDB has high performance, rich query language, and the queries of MongoDB is quite simple. Like it's not complicated. those like in rdbms, if you see, rdbms has a lot of complicated queries like joins and all, so those makes the query too complicated. But mongodb queries are rich query language, and it's a simple to predict and understand the query languages. Okay, so let's check basic thing about how a rdbms to NoSQL mapping looks like. Let's say you have in rdbms a user table, a user skill table, and user experience table. Okay, so basically the data is not stored onto the same table, but it is stored onto different tables. Okay, so denormalization and normalization is what we talk about, right? So but with NoSQL databases, I said joins are not there in NoSQL databases. So how do we handle that? Because what we try to do is in NoSQL database, especially in MongoDB, we try to maintain all the data into a single document itself. Okay, so instead of maintaining multiple tables, okay, we will try to maintain it into a single document. Like users are there, so user data is over here, first name, last name, and skills. Again, within the same document, we can maintain a skills as an embedded document or an array. Okay, instead of maintaining multiple tables, we will try to maintain a single collection and maintain all the data into a single document, thereby avoiding the requirement of joining multiple tables. Joining is always costlier, be it performance wise or maintenance wise and all as well. Okay, any questions until now? Yeah, so when it comes to lookups, yes, I'll talk about that. Lookups is there, but like I said, in rdbms or any other rdbms databases, SQL or Oracle, you have a lot of complicated joins, left join, outer join, inner join, and all those things. But just because there was a requirement from few of the applications to have joins concept, they have invented or implemented the lookup change recently, that is to join two tables. But mostly when you do a data modeling for a MongoDB, it is always preferred to maintain all the data into a single database, single collection only, instead of maintaining it in a multi collection way. Because again, if you have to join two collections, it is again costly for you. But if there is a requirement, if that is your requirement and you have to have joins and you have to separate the data, then yes, you can use the lookup. But that is a last option. Even during data modeling concepts, when we talk about, we always say that should be a last option to segregate the data and store it into a multi tables. Let's talk in tables way right now, but in MongoDB we call it collections. So for your understanding, I'll use the term tables for now. So instead of maintaining multiple tables, we always design our data to store in a way that it is stored into a single table. When it's possible, why should we store our data into multiple tables? Okay, so query issues such as high cost and execution time for what we mostly do, query optimization. Is that a case in MongoDB too? Yes, definitely. Like I said, any of the database concepts will remain the same. The core basic database concept will still remain the same. The indexing part, the optimization part, the cost when you use the index, or cost when you do joins and all, those still will remain the same. But the only change is how you store the data, how you maintain, and overall throughput of the queries that you're using, that has been improved. The basic concepts will still remain the same. If you have been into a DBA role since last few years, those concepts will not go in vain. You can still implement those concepts, but just reinvent yourself into adjusting to a new concepts like sharding, replication, or normalizing the data, all those things. Okay, and templates, what factor must be considered for MongoDB sizing? So again, this is a high level requirement that we need to consider. Like it depends upon your business. How much data are you going to expect? So accordingly, you have to size your data. Like if it's a normal application, it's a read heavy application, we generally suggest for a replication and all. So I'll come to your point in a while when we discuss about replication and sharding in MongoDB. Okay, so MongoDB has basically three types of setups. One is a standalone, okay, and standalone is implementing your server or implementing your data into a single server, which is basically only used for practice purpose. It's not even used into QA or staging purpose. It is only for if you are learning your MongoDB concepts and you want to test on locally something, then you can implement a standalone. Then there is replication. Replication means the same data will be replicated to different members and it will be stored over there. So that means it is data redundancy. But since we are storing it into a commodity hardware, it won't be too costly for you. Why are we replicating the data? That means, let's say you are deploying your data onto a different machines, and obviously if it's a commodity hardware or if anything, if a planned maintenance is happening, so you have to bring down your machine. So let's say we have a replication, we have three machines available having the same data. By default it will be reading from the masters, let's assume. Let's say we have a maintenance and for some point, at some point we have to bring down the master, right? So even though one of the member goes down through planned event or through unplanned event, there are still two other machines available which has the same data. So you can read the data from those available machines. So at any point of time, you will have your data available. Let's say online retail markets, maybe let's say Amazon, Flipkart, or any of those applications or sites that we have. At any point of time we should have the data available. If not most recent data, at least we should have some idea what are the things available. Eventually it will be having the consistent data or availability of data, but at least you should know the data, right? If the server is down, then your application, the Flipkart site is down, that shouldn't happen. So at any point of time, the Flipkart site should be up and I should be able to browse through it. So that is the reason when maintaining multiple machines having the same data comes into picture, so that you can keep your system up and available at any point of time. Okay, so basically the structure of a simple replication in MongoDB looks like, let's say we have a three-member replica set. So we'll have a master, which is called a primary. Guys, is this available or is it in a smaller format? Should I maximize it? Anyone? Is this visible for you guys, or should I
Yeah, it's all
zoom?
visible.
It's visible, right? Okay, good. Because you should be able to understand it. Yeah. So let's say a replica set. What does a replica set architecture look like? A simple replica set might have at least three-member replica set. Okay, this is the basic. You can also have a single-member replica set, but that doesn't make any sense. So you should have a three-member replica set. So when I said the data will be replicated, by default all the writes will be going to primary, and then from primary the data is replicated onto the secondary. That way at any point of time you will have three copies of data, one on primary and the two copies onto the secondaries available. And at all the time these will be communicating with each other. The secondaries will be communicating with each other and also secondaries will be communicating with the primary. Thereby it will get to know if they are up or not. Let's say some issue happened on primary. Okay, some issue happened on primary, and that system is not available. Now the secondaries will be available, so they will be uh, you know transferring the heartbeat between each of them, so it will also try to communicate with the primary. So if these two secondaries are not able to communicate with primary, they will decide that okay, the primary is down, so now one of these two will become the primary and your system is up and running. Even though this is down, it's still highly available and your data is still accessible by the client or even you. So that's how a simple replica set works, maintaining a high availability. So when does a sharding comes in? The sharding is, again, just now we spoke about horizontal scaling and vertical scaling, right? So sharding implements the horizontal scaling concept. Horizontal scaling is nothing but distribution of your data across multiple machines instead of storing all the data onto a single machine. Okay, let's say you have data of 10,000 records. So instead of storing all the data on the same server, you will store the data onto two servers, 5,000 on one server, 5,000 on two servers. Let's say the server on which you're storing 5,000 records has gone down. Even if right now assume that it's a single server. Okay, if it's a replica set, then even if one member is down, the other two members should be up, right? But let's assume that it is a single machine. Single machine has 5,000 records, the other single machine has 5,000 records. Even if one server goes down, okay, you will still have your one server available. Let's say these two are on multiple DCs. Let's say Hyderabad and New York. Let's say some natural calamity has happened on Hyderabad location and this DC is down. So that doesn't mean that your complete system is down. Though the DC on Hyderabad is down, you still have the DC in New York available, and your clients who are from New York or who want to access the products from New York, they'll still be able to access them. So your system is not completely down because you're maintaining across different DCs, different locations. Getting my point? Sync to primary server. Uh, Yeah, I mean, I'll do one thing. I'll just complete. I mean, you can ping me, your post me your questions and all as and when you get the questions because you might forget as well. But I'll just finish these topics and then we'll go with the Q&A session and we'll go through all the questionnaires that we have. Sounds good? Yeah, great. Yeah. So the sharding concept is basically implementation of the horizontal scaling of your data. It's not just about a failure data. I mean, DR or disaster recovery or something like that. A complete data center has gone down. It is also that let's say your all data is stored onto a single machine, the 10,000 records. So by default, all the queries will be hitting the same server, so that the too much load will be onto the same server. If you distribute this data 5,000 on one server and 5,000 on other servers, then the data you are querying will not go. The entire load will not go onto the same server. The load is also distributed here, right? So whatever data is stored on the second shard, those queries will be routed to the second shard. Whatever data is stored on the first server, the 5,000 records, those related queries will go to the first server. So that way, we are also reducing the load on each server by distributing the load. We are storing the data across different machines so that we are distributing the load, and also we are prepared for a disaster of a particular data center. Okay, so like we spoke about replication, there is a primary, there is a secondary. So these are basically two important components when it comes to a replica set. There are also other components like arbiters or delayed members and all. So but majorly we have to concentrate on primaries and secondaries. So primary is where, let's assume it's a master, all the default writes and reads goes to the primary, and from there the data is copied to secondaries. From primary the data is copied to secondaries. Okay, and when it comes to sharding, basically it has majorly three components. There is a shard, there is a MongoS, or there is a config servers. So what are these three? What is the job of these three components that we have? Basically, shard means it will store the actual data. The 10,000 records I'm talking about, those data in a sharded cluster will actually be stored on shard components. Okay, and config servers are those which store the metadata information, like 10,000 records are distributed, 5,000 on one server, 5,000 on the other server. So now the config server will have the data about which records are stored on which server, so that you don't have to search on both the servers. You can directly go to config server, get the data about which data is stored on which shard, and directly go to that shard instead of going to both of them. That will save your time. And Mongo is basically the client facing server. It is what all the operations, all the queries are executed through the router or a Mongo server. Mongo server is also called as a router server. So if you see this image, you can see the architecture, default architecture that you have. Let's say you have a two shard configuration. You can have a single MongoDB instance or a two MongoDB instances, and it is only one config server that will have. So config server will basically have the metadata information about the actual data. The actual data will be stored onto a shards, and mongoose is where the client, let's say application servers means the clients will be directly talking to router servers. They will not be talking to shard servers or config servers. All the queries will be going to router servers. So router servers or a mongoose instance will communicate with config servers, get which shard is the data on, and directly will go to that shard. So this is the major one, communication purpose. And shards is for storing the data, and config servers is for storing the metadata information. So this is the basic architecture of a sharded cluster in a MongoDB. Okay, so again, in MongoDB, not every database or not every collection is a sharded collection. That means you have to define which collection has to be a sharded collection or a non-sharded collection. What is the difference between these two? Sharded collection will store the data across multiple shards, whereas non-sharded collection will store only data on a single shard. So that is how it is there, that you have to define and execute the commands and define which collection should be a sharded, which collection should not be a sharded one. Okay. So performance wise, yes, MongoDB, like any other database, uh, at a simple default settings, it might not work well. You have to fine tune your databases in order to perform well. So for that purpose, you have, locks are also available in MongoDB. So you have to handle your locks. Okay. And memory usage or number of connections or replication lags, these are different things that are available. You have to fine tune depending upon your requirement. Not all the deployments or not all the applications or databases that are deployed will have the same default setup. Depending upon your requirement, how your application works, you have to fine tune your applications. Okay. So yes, we'll take some questions now and we'll discuss about it. Okay, so there's a question from Sasanka. Sorry if I'm pronouncing it wrong. Yeah. So when the primary gets shut down, one of the secondary will become primary. What will happen if the primary gets up? Very good question. So what happens is, if there are three member replica set, like we spoke about, okay. So let's say there is a three-member configuration. So let's say this primary, because of some reason, it has gone down. Maybe a network issue or some issue. The system has crashed on the primary, so it has gone down. So now one of these two members, like how will that happen also, I'll explain in short. So each of the members will have votes assigned to them, votes and priorities. Okay, so by default every member will get one vote. So if this primary goes down, automatically there will be an election implemented. Now these two members will try to communicate with the primary. Now if there is no primary is a master. If there is no primary, then election will happen between these two members, and one of the members will become primary. That there are different scenarios again which are implemented in the backend. You don't have to worry about that. This is automatically done. You don't even have to jump in to initiate or to make one of the member as primary. It is automatically happening, auto failover. So one of these members will become a primary depending upon the most whichever has the most recent data, and it will become a primary. Even if the previous primary which is down, we have fixed the issue and we have bring it back, it will still be the secondary, and the new primary whichever is elected will still continue to become a primary until and unless you force it to become a secondary, or you force it to step down, or some issue happens on that primary. Until then, the new primary will continue to become or to stay primary. Did I answer your question, Sasanka? Once a new primary is elected, it will stay primary unless and until it is forced to step down. Sync to primary server. uh, I did not get this question. Is that mean that data is synced from the primary server? If that is the case, yes, data is synced from the primary server using the op logs. there's a concept called oplogs which is followed in MongoDB. So using the oplogs will be copied onto your secondaries even every frequently every 1 minute, or even if you define a size for oplog, so eventually those data will be copied onto your secondaries. So that thereby it will be in sync with the primary at all time. There, if there is if the if the member, one of the secondaries is out of sync, you can set an alert. It is called replication lags. So replication lag again can be because of different reason, maybe a network latency, maybe some issue on the server, the secondary, which has a replication lag. So accordingly you have to troubleshoot it and you have to fix it. But 99.9% of the times all these members will be in sync. Not even a millisecond of lag will be available. It's always there. So any other question? Yeah, sizing. Like I said, MongoDB, depending upon your requirement, you can upscale or downscale your data. I mean, you also have you can upscale or downscale using sharding concepts. Okay, so if you have too huge amount of data that you have to handle, then you can go for a sharded cluster. And when there's a requirement, you can add new shards onto your system. And when it is not required, you can reduce your shards and you can maintain it if the data is there. With a normal amount of data which can be handled onto a single machine, you can go with a simple replica sets. There are again different criteria or different scenarios that you have to explore, and then accordingly take a decision about going with a replica set or a sharded replica set. Did I answer that? Does it require two more storages for backup? Praveen, I mean, any can you elaborate this? I mean, I'm a little confused with the question.
Yeah, so you said that the two others are secondary. So if there is a minimum data, means minimum storage of the minimum data we have. So does it
Mhm.
require two other more secondaries every
Yes,
time?
even if it's a single record, even if it's a single record, it will be replicated onto the other members as well. That is what a simple replica set means. It is same data which is replicated thrice. If you have a three-member replica set, you have the same record copied three times. That is because you want your data to be available at all times, right? So that is the reason. So, and also you're not implementing this MongoDB onto a high-end servers. You're implementing it onto a commodity which is low cost. So you can still take, irrespective of maintaining multiple machines and multiple copies, it is still less costlier than maintaining a single high-end server. It also advantage of keeping your system up and running at any point. Even because of a single failure of data, it should not affect your overall applications or overall availability of your servers or sites. Right.
Yeah. So one more question I have, last question. So
Sure, sure.
dynamic schema is there. So it's a
Yes.
best benefit of it, but how it does it? Like whenever I need to update one column, so how it does, and does it lose the whole table and create a new one?
No, that is the beauty of NoSQL databases. So if you have to insert a new what you say, new column or new entry, new field to a document, you can just insert it. You don't have to run anything. Just add that field to the document. Like insert command will be there, right? In the insert command, instead of those three fields, you will also add this fourth field and you insert it. It will automatically maintain. The older documents will still have the three field values. The new document will have the four field. If you want to update, you can update the older document and add the new field. It is not required that all the documents needs additional field, right? Let's assume you have phone number field. Okay, you have a phone number field. Only few of the people might have two phone numbers. The rest of the people are only having one phone number. So it is not required for you to maintain two fields for that, right? Phone number one, phone number two. For whatever people have one phone number, you'll only store one phone number. But if they have two phone number, no problem. You can insert two fields, additional fields, or within the phone field, you can maintain it as an array and insert two values into that. Does it make sense?
Okay.
Yeah. So is there any difference in MongoDB sharding and replication compared to Rdbms? Um, I'll explain what I understood. So is there any difference between replication and sharding in a NoSQL database, right? So basically, replication is maintaining multi copies of your data. Okay, so a single copy is a single document is stored on 3 servers, whereas sharding is storing your data in 2 servers. All these all these three copies are there, though they are maintained on 3 different servers. We'll consider them as a single server because they have the same type of data, whereas sharding means they'll have different data. First shard will have first 100 documents, second shard will have second 100 documents, and again you can maintain this first server as a replica set so that you will have 3 copies of these 100 documents, and the second one also will have 3 copies of each of them. So interrelated. A sharded cluster can also have a replication, but not the reverse way. The replication doesn't mean that it has sharding. uh, does it make sense? Yeah. So any other questions, guys?
How keys will be there in MongoDB? How keys will
Sorry.
be more part of the keys? Primary key, there's other keys are there. So how will be matter in this MongoDB?
So MongoDB, like I said, primary and secondary keys, these are mentioned when you have to join 2 different tables, right? So that is the reason we avoid the concept of multi-table concepts. In MongoDB, basically we call collections. We don't call tables, we call it as collections. Okay, so that is the reason we maintain in a single collection. And MongoDB doesn't have primary or secondary key, but we have shard keys. So shard key is something which defines how you distribute the data across multiple servers. Like I talked about 1,000 records or 10,000 records, which will be distributed 5,000 on one server, 5,000 other server. If you define the shard key, depending upon that shard key, it will distribute the data. That is the only major key that we have. The rest we have indexing concept as same. We have different types of indexes available. There is a simple single field index, there is a multi-field index, compound index, or multi-key index. There is a geospatial indexing also available, text indexes. There are different indexes available depending upon your requirement. So as and when you change your data or change your requirement accordingly, you can create the index and maintain it. Again, the concepts of the DBA, a normal RDBMS concepts also works here. Too many unnecessary indexes also will have a uh, will affect your overall performance of your databases.
Is it a auto-generated key, right? The shard
Which one?
key will be
No,
auto-generated.
shard key is something you have to define at the time of creating your databases or defining. Like we spoke about a while back, we have, even though we have a sharded cluster, that doesn't mean the collection that we are storing. Collection in the sense table. In general RDBMS terms, it is a table. So just if each collection by default it will not be a sharded cluster. So you have to define the shard key. It is up to you because if it is automatically generated, it might not be effective, right? So that is the reason they give you the option of selecting the fields on which you have to apply the shard key. So thereby the data is distributed. You will know today on an empty database, you don't know how you're going to get the data, but you can analyze and you can estimate, okay, this is how the data is going to generate. Accordingly, you will decide which fields to create a shard key on.
Yeah, thanks.
Okay. So any other questions?
That's good.
Guys, anyone else? Anything, even if it might be a small question, you might think silly, but trust me, nothing is silly when you're trying to learn.
You have there's a multiple shard, right? Shard A and
Yes.
shard B that you showed.
Yes.
So
Yes.
how they will like join means there's no join concept, but if you want to both collection at the same time, both shard.
Mhm.
So how we will get the both shard at same time?
So, like I said, by default, the data or the applications will not be interacting with the shards directly. They will be interacting with the MongoS router servers. So even the write operations will be going to router servers, and router servers will check with the config servers, and depending upon the shard key, it will go to shard 1 or shard 2. So this will do all the operations for you. The load is not completely onto the shard, because if everything is done at a shard level, then again too much load onto the shard, even storage wise, and also processing wise. Processing is all done at router level.
Yeah, correct.
So from here, you will get the idea about where the data is stored. That is the reason we are maintaining config servers, right? Because you store the data, but you don't know where the data is stored. Maybe you will, if you query it, you will get it, but that doesn't require, right? So you will create a shard key. So when you're querying it, you will pass that shard key as part of your query and all. So from that, it will search, okay, which shard should I go on, and it will go to that shard and it will retrieve the data.
Okay, got it. So we should require only the shard key, not nothing else.
Yeah, yeah, sure, sure. So, yes, Vishal, we are recording this. It is being recorded. Any
Okay,
questions,
okay.
Vishal? Yeah, sure, sure. Any other questions here, guys? Great. I think at least I have given you a basic understanding about MongoDB. I mean, still there are a lot of concepts to cover, and I tried to give you a basic understanding outline of what MongoDB and NoSQL database is. Hope at least I gave you a initial push that you can learn how what MongoDB is.